Hello everyone, and welcome to the much anticipated sequel of Rational Expressions. In this video we are going to do a little bit of dividing and a little bit of multiplication with rational expressions. So what we're going to do is, let's start with a little dividing. Let's say we've got 12x to the fourth y squared over let's go 40 a to the fourth, b to the fourth. Let's say we're dividing that by 6x squared y to the fourth, and let's say 16a squared x. Okay, so dividing gets a little tricky, so why don't we make this a multiplication problem instead? Okay, we can change this to, because dividing is just the same as multiplying by the reciprocal. So let's rewrite this, x to the fourth y squared over 40a to the fourth b to the fourth. And let's change it to times, and let's flip this, okay? So let's multiply by the reciprocal. So up top we now have 16a squared x, and on bottom we have 6x squared y to the fourth. Now, you could, as you all know how to multiply fractions, just multiply straight across, okay? You do 12 times 6, x squared, or x to the fourth times x, get the x to the fifth, blah, 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 blah. Or, you could come in here and cancel what you can at first. So see how this x squared is on bottom and this x to the fourth is up top. We can cancel this or divide, okay? And give us, this x squared goes away, and this would become just x squared. This y squared up here would cancel, and this would become y squared. The 6 would also cancel and would go into 12 two times. So far up here, what we've got left is 2x squared. Okay? Now over here, a squared could go into the a to the fourth, leaving you with just squared. And 16 and 40, well, those both divide by 4. So we could go 10 and then 4 left up here. But hey, now look over here. We've got 2 over 10. Well, 2 goes into 10 5 times. So now all we have left over here is just x squared times 4x. So that gives me 4x cubed. And then on bottom, we've got 5a squared b to the fourth times y squared. Okay, now you could have just multiplied this with x to the fourth y squared over, let's see, we had 40 a to the fourth b to the fourth, and then times, we got 16a squared x over 6x squared y to the fourth. Okay, you could have just gone straight across and just simplified from there, and you would have ended up with the same thing. This just involves a little less multiplication and a little bit faster simplification. Okay, so let's look at a new, let's do a little multiplication. Let's go 6xy over 15ab squared. And let's do this times, let's go 21a cubed over, let's go 18x to the fourth y. Okay, now this is just multiplication, so again, we could just multiply straight across 6 times 21 xy times a cubed and get a term on the top, and then simplify blah 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 blah. Or we could go, hey, 6 goes into 18 3 times, and x goes into x to the fourth once, leaving me with just x cubed, and these y's just completely cancel. Now look over here, a goes into a cubed once, leaving me with just a squared, and 15 and 21 both divide by 3, leaving me with 7 and 5. So over here I have 5b squared times 3x cubed, leaving me with 15b squared x cubed. And up top, this term completely canceled, leaving me with just 7a squared. And that right there is the quickest way to simplify multiplying or dividing rational expressions.